Hello, this is Joy Zeigler, and I'm here to teach you about Lesson 11.3 from Section 11.3 in your textbook. Your first lesson for Math 310 is actually a review of a lesson near the end of Math 308. This is going to cover things about lines. For instance, we're going to talk about the slope of the line and how to find what the slope is, how to use the slope to decide if lines are perpendicular or parallel, and then we're going to look at some word problems. So to start with, what is slope? Well, slope, all that is the slant or steepness of a line as you look at it from left to right. And by the way, you want to be following along in your book on page 799. But you also want to have these notes in front of you so that you can fill them in as we go. So the slant we've just talked about, that's called the slope, and it's a single number which tells us the direction in which the line is slanting as well as how much slant is on the line. So the direction is going to be either positive or negative, and we look at it from left to right. So if the line slants up or runs uphill as we look at it from left to right, that's going to be a positive slope. And if it slants down or runs downhill, it's going to be a negative slope. So now that you know that, the larger your slope is, the steeper your line will be. So if you have almost no slope, it's like a roof with almost no pitch to it. It's going to be very small. Now you know everything you need to know to go skiing, and when you see the sign that gives you all of the different slopes for their different slopes, you know which slope to go to. But seriously, if you can tell the difference between a positive and negative slope, then you will get twice as many answers correct on your test than someone who doesn't know that, because you can check your answer and make sure that if your line's going uphill left to right, then it's a positive slope. So the slope is the difference in the ratio of the vertical change in y to the horizontal change in x. So what do I mean by that? It means that we're comparing how high it rises to how far over it runs. In other words, we're comparing rise to run. Rise is the difference in the y direction, and run is the difference in the x direction. In these graphs, we have a slope on a line. We know the slope is negative because it's running downhill from left to right. Over here, we know the slope is positive because we have to climb the hill from left to right. So on the first diagram where the slope is negative, we're given several points on the line, and that's helpful because we want to compare how far the line rises to how far the line runs. And we do that looking at 2 points on the line. So if only this point and this point existed, then we want to know how far does the line rise from here, which is where this point is, to here, and how far does it run from here to here. So all we have to do is count the lines. It rises 1, 2, 3, and it runs 1, 2, 3, 4, 5, 6. So we know that the line is going to rise 3 and run 6, which is the same thing. Well, we'll get to that in a minute. But is it going to be positive or negative? Well, we've already said it's going to have a negative slope because it runs downhill. So that's a negative 3, 6, and then we reduce it and we get negative 1/2. How about over here? We start here and we end there, just 2 points, so we don't have to choose any points. But notice over here, we could have chosen any 2 points and we would have gotten the same slope. So over here, y equals 1 here, and it rises 1, 2 to get to this point. So our numerator is going to be 2, and for our denominator, it runs 1, 2, 3 to get to this point. So our denominator is going to be 3. And since the line runs uphill from left to right, it's a positive slope. So our slope is 2/3. Now, if you know the values of the points, for instance, in this problem here, we know that the first point on the left, well, here's a little review for you. You find the x value. X is 0 where the axes cross the line. So -1, -2. X is -2 at this point. So we write down, I'm going to put that in blue, we write that that point is -2 for x, and what is it for y? Well, again, we start at 0, 0, and we count 1, 2, 3. Y is 3. So that point is -2 and 3. This point here is going to be x equals 0. You start at 0. I'm sorry, y is 0. X is equal to 1, 2, 3, 4. So x is equal to 4. And then when you start at 0 and you count to y, well, y doesn't rise any, it just stays at 0. So y is equal to 0. And if we're talking about rise over run, it's very easy to count the lines if you're given a graph. But what if you're just given 2 points? Well, the way you tell what the rise is you find the difference in the y values for your numerator. So in this line, your difference of the y values are going to be, we'll start with 3. It doesn't matter which point you start with, you just have to be consistent. So 3 minus 0 is 3, and -2 minus 4 is -6. So in these two graphs, you have, in the first case, a line that has a negative slope because it runs downhill from left to right. In the second case, you have a line that has a positive slope because it runs uphill from left to right. And we need to find what the value of the slope is. So we can take any 2 points on the left. We can take this one and this one, or any other 2 points. And what we need to do is we need to find out how far it rises. Well, in this case, it falls. From up here it falls 1, 2, 3 points. And then how far it runs. Well, the fall or the rise is going to be your numerator. And how far it runs, we start here and we go 1, 2, 3, 4, 5, 6. It runs 6. So we put 6, and since we can look at it and see it's running downhill from left to right, it's a negative. But if you put -3/6 in your homework, you're going to get it wrong because you haven't reduced it. So we then do what we love to do and look at slope as a fraction, and then go ahead and reduce it, and we get -1/2. So what's the slope for this line? Take a minute and figure out what that slope is. Okay, so we look for the rise in the slope. Well, it goes from this point up 2 to get to that point. So the numerator is going to be 2. And then we look at the run in the slope, and it starts here and runs 1, 2, 3 over to the right. So the denominator is going to be 3. And is it going to be positive or negative? Well, the answer is positive because it runs uphill from left to right, so that makes it a positive slope. So it's very easy to find slope if you have a graph. But what if you just are given the values of the points? For instance, in the graph on the left, the first point, let's review a little bit. The first point, x is going to be -2. We know that because here is 0, 0, and on the x-axis we have to move to -2 to get to that point. So y, we have to move up 3 to get to that point. So y is going to be 3. And on the other point, x is going to be 1, 2, 3, 4. And y is 0 because it doesn't move away. It doesn't rise any from the y equals 0 mark. Where the axes intersect, that's where x equals 0 and y equals 0. So the second point is 4, 0. So what if we were not given the graph, but we were just told what these 2 points were? There is a way to calculate that, and it's the principle of the change in rise over the change in run. So the rise is the difference in y values, and the run is the difference in x values. So if you're given a point, and we'll call it x1, y1, here we'll call it x2, y2, you can calculate the slope by simply subtracting the y's and then putting that over the difference in the x's. So the formula for slope is y2 minus y1 over x2 minus x1. And remember to be careful with your signs. You should be able to just plug in your values for x and y, and it'll show you what your sign of your slope is. And then also be careful to reduce your fractions. So on the chart down here, on the graph down here, what is the slope? Is it positive or negative? The answer is that since the line runs downhill from left to right, the slope is negative. And what is the slope? Well, since we're given a graph, we could use our formula, and we could, let's do it both ways. First, just looking at the graph, we start at point P and we say the rise is 1, 2, 3, 4. So that's our numerator, 4. And the run is 1, 2, 3, 4. So we have another 4 for the run. And when we reduce it, we get 1. And the slope is not positive, it's negative because it's running downhill. So we have a negative sign in front. So our slope is -1. Or we could use our formula that says that slope, we'll call it m, is y2 minus y1 over x2 minus x1. So here we're going to have x1, y1. Remember, x always comes first. x2, y2. So let's write it in red. We have our slope is y2, which is -1, minus y1, which is 3, over x2, which is 6, minus x1, which is 2. So that's going to be -4 over 4, which is -1. So we got the same answer using our formula as we did just looking at the graph. Does it matter which point goes first in your formula? And the answer is no, it does not. And does it matter which 2 points you pick on the line? And no, it does not, because they'll still have the same slope. So find the slope of the line that contains the points -4, 7, and 1, -2. So we use the slope formula. Let's pull this up. That y2 minus y1 on top, which represents the rise, x2 minus x1 on the bottom. So that's going to be our slope. So we'll call this x1 and y1, and this x2 and y2. So y2 is negative 2 minus y1, which is 7, over x2, which is 1, minus x1, which is negative 4. Now, when we have minus a negative, that's the same thing as plus a positive. So we have minus 2 minus 7, which gives us minus 9 on top, and 1 plus 4 is 5 on the bottom. So our slope is 9/5. Pause the video and find the slope of the line that contains the points negative 9, negative 2, and 12, 5. Your answer should be that your slope equals 1/3. And if you need more practice, work these problems on pages 800, 801, and 802. The answers, the problems are in the columns on the side of the pages, and the answers are at the bottom of the pages. But now let's go ahead and look at graphing horizontal and vertical lines, which start on page 803. So let me write that. Page 803, starting, well, down here. So consider the slope of this line that is on this graph over here. If that were a roof, the roof would have no pitch. The pitch would be 0. So if a line is flat like that, it has no slope. So the slope of a horizontal line that is flat is 0. And the graph is going to be, well, x doesn't change, but y is always going to be negative 1. So look at this. Here's where the x and y values axes cross, and y, if you count down, y is negative 1. It's negative 1 everywhere on the line. So x changes. X is 1, 2, 3, negative 4 here, negative 2 here, 0, 2, 4. But y is always negative 1 in all those places. So to define that line, the equation is going to be y equals negative 1. There is no x value in the equation, and you know that because the line crosses the y-axis at negative 1. But what if it's a vertical line, a line that goes up and down? In that case, the slope is not 0. If you think of a roof that stands up straight, it lets in all the rain and everything because it stands up straight. It's a useless roof. So that's one way to help you to remember. The slope of a vertical line is undefined. Mathematically, I'm going to go ahead and write out the word. Mathematically, we know that because if we use our slope formula, let's say for this 2 points, negative 1, 3, and negative 1, negative 1, well, we will have x1, y1 is negative 1, 3, and x2, y2 is negative 1, negative, that's not right, what is it? X is negative 1, y, oh, I see, the points are at the wrong places. So we're going to use this point up here, negative 1, 3, and negative 1, negative 1. And so our slope is y2 minus y1, which is negative 1 minus 3, over x2, which is negative 1, minus x1, which is negative 1. So we have negative 4 over negative 1 plus 1, which is negative 4 over 0. Well, if you'll remember, anything divided by 0 is undefined. So you cannot divide anything by 0. It's an undefined operation, and that's why our slope is undefined. The slope-intercept form of the equation is something that you will be able to discuss with yourself while you're sleeping. That's how much you're going to be using it. And the equation for that is y equals mx plus b. You probably remember that. You probably remember that either from your last math class or from high school. And you probably already discussed that with yourself in your sleep. So, couple of points to notice are that y equals mx is a straight line that passes through the origin. The origin is where the x and y axes meet and intersect. So we'll call that the origin, which is the point 0, 0. Y equals mx plus b is a straight line that crosses the y-axis at B, so that it has a y-intercept of 0b. So where a line crosses the y-axis is called the y-intercept, and it is going to be where x equals 0 and y equals b in this equation here. And m represents the slope of the line. So here we have y equals mx plus b, where m is the slope and b is the y-intercept. So if we see a line on a graph and we can figure out 2 points in that line, we can find the slope by calculating the rise over the run, and we can look at the line and see where it crosses the y-axis, and that will give us b.